Hello everyone. Today we'll be looking at a counting puzzle. Right? We have to find the number of terms in the arithmetic sequence 11, 19, 27, 35, and on up to a certain number, m plus 8, where we don't know the value of m. And we have to find the number of terms in this sequence in terms of m. Right? So let's look at how we can do this. Well, we know the common difference, which means the difference between consecutive terms in this sequence is 8, right? And if you look at if you look at each term in the arithmetic sequence, so we'll look at 11 first, it's 8 times 1 plus 3, right? 19, 8 times 2 plus 3. 27 is equal to 8 times 3 plus 3. And then this continues until m plus 8. So it'd be nice to turn this sequence, 11, 19, 27, into something like 1, 2, 3, 4, on and on and on, while preserving the number of terms in the original arithmetic sequence. Because if we turn it into a sequence like 1, 2, 3, 4, it'll be easier to count. Right, so how are we going to do that? Well, first of all, look at how we have a sequence already of 1, 2, 3, 4, and so on. Right, if we do this for 35, it's 8 times 4 plus 3. So you want to get rid of this plus 3 and this 8 times multiplicative factor in order to get our sequence of 1, 2, 3, and 4. And doing the inverse operations of plus 3 and times 8 will preserve the number of terms because we're doing it to every single term. So let's start by subtracting 3 from each term in our sequence. Then our new sequence will be 11 minus 3 is 8, 19 minus 3 is 16, 27 minus 3 is 24, 35 minus 3 is 32, and then our last term will be m plus 8 minus 3, which will be m plus 5. Right? So this is our sequence of multiples of 8. And this has the same number of terms, because we subtracted 3 from every term. So it doesn't change the actual count of the numbers. Right? And now I think the next step is pretty logical. We'll divide each term by 8 because they're all multiples of 8. Right? M plus 5 is also a multiple of 8 because m plus 8 is 3 more than a multiple of 3, like we examined above. So m plus 5 divided by 8 will be an integer, no matter what. So we will have the sequence 1, 2, 3, 4, all the way up to m plus 5 divided by 8 as our final bare bones sequence after dividing each term up here by 8. Right? We divide by 8 and then we get the following terms. Right? Just like that. Now we can just count the number of terms here. So how many terms are in this sequence? Right? Well, there are m plus 5 divided by 8 terms. Right? Because the number of terms in a positive integer sequence starting from 1, so like the number of terms in the sequence 1, 2, 3, 4, 5 is just going to be the value of the last term, which is 5. There are 5 terms in the sequence 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Likewise, there will be m plus 5 divided by 8 terms in our original arithmetic series above. We can look at it up here. This one. This sequence has m plus 5 divided by 8 terms. And that's our final answer.